Do you want to become a DevOps engineer or want to transition to a DevOps engineer from any other job roles, which are sooner or rather than later will be replaced because of cloud migration? Then please join me in the webinar where I talk about how and why we need DevOps engineers and why there is so much demand for them. And in that webinar, I demystify step by step the technology, tools needed to become a successful DevOps engineer, and plus how to achieve that using a right, practical, easy to use steps.
And welcome to this lecture. This lecture we will talk about what is DevOps and a quick introduction to DevOps if anybody is looking to migrate to it. And this applies to pretty much anybody who is interested in DevOps and someone looking to explore more about it. So before I begin talking about DevOps, let's talk about the prime drivers for DevOps. What exactly has led to such a wide adoption of DevOps philosophy, principles? And these are these in the slide you can see, they are the primary two driving forces. One is your agile based SDLC, which demands very fast delivery of software. So I'm talking about higher code velocity. If your developer is writing a code and you want to push that code into production as soon as possible, you have to adopt agile philosophy, agile methodology, and how to implement it in a software development lifecycle. You have to use DevOps philosophy. Second is the cloud migration, because businesses have realized that this is the single most biggest thing they are going to do. Big investment is going to happen or is already happening as far as the IT infrastructure modernization, which is happening across the industry. Doesn't matter which industry you are, you may be pharmaceutical, you may be a hospitality, you could be pizza delivery shop, doesn't matter. You have to be a cloud. If you're not, then basically you will face the consequences of running your application serving your customer in legacy application and hardware, which can dramatically reduce the experience of them, and of course over a period of time you may lose some customers as well. So these two are the prime driving factor behind DevOps, and which is why you can see so much demand for DevOps professional across the board. So let's talk about what is SDLC. SDLC stands for Software Development Lifecycle. This software development lifecycle predominantly people have always synonymously used with waterfall. So anytime you're talking about a SDLC, they're talking about a software development lifecycle based on waterfall model. In that, what you do, you start with requirement. You basically gather the requirement, and requirement gathering could take a lot of time. And then you basically come sit with a designer or developer, you start designing it, the estimation, and then you do the development, testing, and implementation. This is a very classic approach of doing that. And this has been done for, I will say, many decades, and it was a very successful model, and pretty much all software which you see right now has been designed using waterfall model. However, in past decade or so, the market changed a little bit. What happened was that as the new businesses were coming up and everything, and new startups are forming and new business ideas and business models are developing, in that kind of scenario, the software design team faced with a challenge. What they saw that the requirements were not clear, and they had to design something out of scratch without knowing the requirement. How will you do that? If you actually follow the waterfall model, you have to have the requirement beforehand. And if it is not possible, then you are stuck. Pretty much you can see in the waterfall model you are stuck. And so so this is one of the biggest thing challenge happened. So again, waterfall has a lot of good things, and some of the waterfall has some deficiency also. So few deficiency I can quickly highlight. That first, as I already mentioned, all requirement must be known upfront. Deliverable created each phase and considered frozen. It means once you have gone through the requirement phase and you are in design and development phase, you're not supposed to go back and change anything. That creates a really rigid structure. And this rigid structure works very well for some businesses which are well established, where processes are defined, everything is done, every stakeholder agrees, they signs, approve, and they move ahead with that. That approach works pretty well. But if you're talking about anywhere the requirement is not clear, even you don't know which developer will work, which technology will work, that becomes really challenging. And of course, when you're talking about the waterfall model, you hear about big bang upgrade. Big bang means you push a really large volume of code into the production whenever you're doing that. And of course, it has pros and cons, and there will be a lot of feature in one release. But flip side, if something goes wrong, you pretty much have to roll back everything, and it could be extremely costly operation, considering as we are moving towards more and more complex infrastructure, complex application designing. These could be extremely costly for anybody, and specifically if you catch a bug at the early stage is good. If you don't catch the bug, if you catch a bug in production, which is many cases it happens, because a lot of time people don't have enough time and energy and resources to do exhaustive testing. So this can be really a costly affair for certain business model. Of course, for a lot of businesses still continue to use waterfall and they are doing very good on that, but in most cases in the modern style it is not as useful as you might think. So if I see a software development life cycle, I want to make it a circular fashion, so I can see planning, analysis, design, development, testing, implementation, and maintenance. Right? It is just like you are building a home, you are building a house. House building, I will say if I want to do it in a waterfall model, how will I do? I'll give the design, I will buy a land, I'll give the design to my architect, architect will complete the design, and they will hand it over to civil engineer or contractors. They will come and build the home, and then you come back after 1 year and you see the house is built. And there is a chance that you may not like the design of the house, you may not like how the tiles were designed, how this were designed. So that creates a problem. I'm just trying to compare with the real life scenario. And same thing could happen with software development also, right? Because when I'm talking about software development, every phase you see bunch of people are stakeholders are there. For planning, you have a business owner, product owner. Analysis, you mostly either do project managers do sometime, but most cases a business analyst does that job. Designing is done predominantly by architects, development is by developer, then QA, and implementation and maintenance usually done by operation team or ops team or DBA, these kind of people. And this works very well for a item like if you are a home builder and you have been building this home for decades, you know the design, you don't know everything is working, and you just build thousands of home and it's pretty everybody's happy. But what about a problem where you build the home but now you don't like it? Same thing can happen with software. I delivered you a software and now you don't like it. How to change it? And as you know, in waterfall model, the loopback mechanism is not very defined, and I will say it's kind of rigid design. So you cannot go back and hey, can you change my tiles? Can you change my this room? Can you change my roofing? That could be a very costly affair. How about this? I give you a design approach in that instead of giving the whole house design, I just give you the design or architecture of the kitchen, and you give the contractor how to make a kitchen. They made the kitchen. Maybe you like, you didn't like. If you like it, you basically say, okay, go ahead and do the rest of the house, or maybe make another room. But if you don't like, the cost of rolling back that kitchen, basically demolishing the kitchen and creating a new kitchen, is much less costly than the demolition of the house. So same way, if I'm giving you a new methodology like agile, in that I will not give you the whole requirement at one shot because I don't know myself. Instead, I will give you a requirement of a kitchen, a very small requirement. Small requirement, you take it, you start working on it, and you move on it. And once I like it, what I do, I give you the next design. And this is a typical style of a agile scrum. Agile scrum, you are talking something like sprint. You are running multiple sprint. So in sprint 1, I choose to create the kitchen. Sprint 2, I try do my like a washroom, and then I do bedroom. In that way, probably it will take the similar time or less time or more time depending on complexity of the project. But good thing about here is that once the house is built, the customer is 100% happy because they had a many chance, many iteration in order to come and give the feedback, and contractors or developers had enough time to change the design and meet the satisfaction of the market or the customer. So this is what it makes is very attractive, very appealing methodology, software design methodology, so that you can meet the market expectation and stay up to the speed. For example, if Facebook changes some small tweak here and there, they change it and if they get a feedback, if the feedback is not good, they roll back the changes. So it's so easy. So it is just trying to correlate with that kind of idea. But as you know, there are no free lunches, because when you are trying to do these kind of things, there will be more work. For example, if you're asking someone, hey, can you do the, because remember, if you're building a one house in one shot, it is actually much cheaper for you, because you hire all contractors at once, they build the home and you get it. But if you are hiring one person at a time or two person at a time, in that kind, it can be very costly, because each time you are doing feedback, you are coming back and going back, it can create a lot of, I will say, back and forth, and it can create delays, and it can create a lot of friction. So in that means that the way a software design team or software development team used to work, it can no longer the same way, because if you continue to do that, actually you implement a design to speed up your process, and then what you do, you are slowing up your whole process. For example, a traditional software development team looks like this. You have a QA people, software developer, and operation. They work in their own silos, and they do pretty well, because you are not interacting with them on a day-to-day basis. You are interacting once in a while, right? So this is the beauty of this, that so you have a software developer working, they give the code to QA takes maybe a couple of weeks testing, and when everything is good, you give to the operation people. And now if you do these kind of things maybe once in a year, twice a year, is fine, because it's okay. But now the sprint example I gave you, right, in this previous diagram, these sprints are actually in agile either 1 week or 2 week max. That's it. You're not supposed to create a sprint of 3 months. Then it defeats the purpose. You need to have a sprint of 1 week or 2 week. This is why you're calling sprint. You're not calling it marathon, right? Waterfall is more of a marathon style. Here, we're talking about sprint. But if I'm trying to do a review, delivery, and testing and everything, remember, I have to do everything. I have to pretty much, if I go back to my software development thing, I have to do pretty much everything. And instead of doing it in a year time, which was in a waterfall style, I'm talking about doing it in a pretty much 2 weeks. And in 2 weeks approach, this type of software development team doesn't work any longer, because it will create a lot of friction. You will not be able to achieve it. So the only solution going forward is that you implement something called DevOps. DevOps team is a developer operation. So this specifically skill set team, or I will say people or philosophy, has to bring into the culture of your software development team, so that they can work in tandem. Now, when the developer develops a code and delivers to the QA, the whole process has to be automated. There is no chance of you are emailing back and forth for approval. No, it has to be completely automated. This is why you hear a lot of time they call about CI/CD, right? Continuous integration, continuous deployment. So it means the moment a software developer checks in the code, immediately your test harness should hook up whatever test harness you have hooked up, maybe SonarQube or something like that, and you start doing the test, and all test automation is happening, and everything is all successful. It has a capacity or capability to automatically promote it to production. And of course, before production, you usually do a pre-prod, something like staging environment. You deploy it and make sure everything is working. You do some kind of post test, or I will say smoke test. And once everything is happy, then probably that time you may have some kind of manual approval process. Okay, this time let's upgrade it, or many cases you can automate this whole thing completely. So you can see, the moment software developer design the code, and if the code has no flaws, it can get immediately deployed in production without any problem. Of course, there is a bug or something, there is the same thing will happen. But in the earlier method, even if the code has zero bug, it will take 2 to 3 months to deploy. And in this approach, if the code has no bugs or maybe less bugs, you can go to deploy. And how you ensure there are less code, less bugs? Because in an agile method, in 2 weeks of time, you can only develop so much. So what they do is, usually scope of the development is also reduced. So instead, before you were building the whole house, now you are building a small kitchen, maybe just a cabinet of the kitchen. So because cabinet of the kitchen has a less lines of code, it is less likely to have a lot of bugs. Maybe a few bugs will be there, they will quickly fix it and go over it. So that way you can make your software delivery extremely fast, or you make your code velocity extremely fast, and via DevOps tooling, which is like automation, a massive amount of automation you do, and makes you so real, I will say real agile, that you get a massive productivity gain. Productivity gain means what? It means two things. Either it could increase the revenue of the organization, or it will reduce the cost or input cost of the organization. Anytime that thing happens, there is a margin increase for any business. If any job role or any philosophy is increasing the margin, those skill set becomes key for any organization, and that's why they are okay to pay a little bit premium dollar for someone who brings that thing, who brings that kind of value and knowledge. This is why this is the one side of the DevOps things. Remember in the back in the slide, the first slide I showed, one is the agile based SDLC, and second I talked about cloud migration. So cloud migration is something like you must be hearing everywhere. People are talking about cloud migration. So what I did, just to give a perspective in terms of dollar value, I just went to AWS and put some server detail, and here I can see that the 3-year forecast what was projected. Of course, it shows 61%. Assuming even in worst case scenario, even if you are talking about 50% saving over 3 years, and I'm talking medium to small size business, it was like a $1 million kind of a project. Whole budget I put, it shows around 61% saving. It means if your IT infrastructure cost is today is like you are burning maybe $3 million in 3 years, you can save right away like up to $2 million. So with cloud migration, the cost is going so down. The majority of the cost saving you can see from the graph, it shows the hardware cost. Hardware cost goes down dramatically. It is like a similar philosophy like Uber. If you want to go from point A to point B, you have two options. Either you buy a car, minimum car, I think minimum cheapest car you get for a brand new car I'm talking about. So you cost around $20,000, right? Including on-road tax and everything. You buy that car, you pay the insurance and pay for gas, and pretty much once you start driving the car, it costs you almost $500 a month, including everything. But if my job is to go only from one A to B, why can't I just download the app Uber and go there? So Uber, when I do that, the cost of ownership goes dramatically low. Right now, pretty much $10, $20, maybe something like that, I can go there. And another thing is that good thing about Uber is that when I don't need the car, I don't have to pay it, right? For example, I'm going to the office, say 20 days, and I'm taking Uber every day. Assume it costs me $50. You will say, oh my God, it costs too much. Let's buy the car. But what about that? Now I'm working from home. So I don't go to work. So what happens? I have no Uber bills at all, zero Uber bills. So that is what the cloud computing is all about. What it is, that the moment you don't need the hardware, you don't pay for it. And how do you do that? A lot of business actually running their hardware. Maybe their business only does maybe 9 to 5, maybe 90 or 9% of the customer they are come only morning time. I'm not talking about website. I'm talking about, say, you are running some batch job in a backend, some kind of tools, or maybe some kind of office software where people only use during office time. So whatever those type of software are there, if you are running those hardware during the off hours, you are actually wasting electricity. You must have heard a lot of time, especially in slowdown season, a lot of businesses what they do a Christmas shutdown, like 2 weeks of complete shutdown. What they do, they simply reduce the electricity bill. And here actually you can do that Christmas shutdown pretty much every day. Assume you have some kind of ERP application which only works like most people use from between 10 to 5. What I can do is I can spin up that ERP application 9 a.m. and shut down at 6 p.m. Just take 1 hour extra. Still you are saving so much of cost. So the server cost with some kind of smart automation, you can dramatically reduce. And keyword here is automation. If someone is using AWS infrastructure and they are just clicking on the web interface and doing this thing, I think they are not leveraging the whole power of it. The main power is that API driven development. So in your development tool chain, you integrate the AWS APIs rather than doing a, I will say, web ops kind of thing when someone clicks and you click buttons. So basically you are making a traditional operation style and you are not gaining, you are of course you are gaining from like a hardware perspective, but I think productivity perspective you can gain with the API integration, which is why I emphasize if anybody is looking to become a DevOps, you must understand a little bit of automation and tooling or any kind of language. And last thing I want to show you here is that you can see the IT labor, that I will say orange bar. Orange bar is actually a little bit thicker in this one in AWS. Why? Because you need a little bit more people, because now a lot of things have changed, right? You don't need hardware. I give you some example. You have to shut down, bring up. So for all these things, you may have to increase the IT labor, and you can see the IT labor cost is almost 3 times. You can see in the 3-year total ownership cost, IT labor cost is 3 times. It means a lot of people think, okay, with AWS, oh, all jobs will disappear. No, actually, it will be more labor required, more people will be required, but of course, it will not be the same skill set people. It will be different skill set people with automation, development experience, or essentially DevOps people. For example, if you're running on an on-prem, you have maybe a team of 5 system admins and 5 DBAs. Once you move to AWS RDS or AWS EC2 or maybe even EKS, I would say a Kubernetes service, you not necessarily need so many system admins. So probably you need one sysadmin, one DBA just in case, and probably one DevOps. And in best case scenario, just you will be hiring 2 DevOps and you don't need anybody because that person will be doing everybody else's job, because that is a multi-hat thing. So this is the giving you a perspective from a dollar side. And what happens is that when I'm talking about such thing, agile adoption plus cloud migration is a massive dollar saving, and this is why everybody wants DevOps, because if you don't have it, they are investing in it because they know whatever the money they will invest, they will recoup that in next 1 or 2 years, even in worst case scenario. So DevOps, so circling back, just a recap on that. The driving force behind DevOps, first is the time to market pressure is high. As I said, startups are there, they want to go to the market as soon as possible. And for that purpose, time to market is very high. Then you're talking about agile practice. Agile practice is like your agile development cycle. And this is very important, is the open source technology become mature. Because all DevOps tooling right now you see, you name it, Jenkins, Kubernetes, Terraform, vast majority like Ansible, Linux, everything is an open source tool. And because open source was not very, I will say, mature 10 years back, right now they are very mature and they are enterprise ready, and enterprise want to use them because they will see massive amount of cost in terms of licensing. So there is no licensing fee anymore. It's just you hire people and they will download the free software, open source software, and of course they have to do something to make it work. So it is more and more labor intensive from a software developer standpoint. Often when I say labor intensive, don't think that they will need more server admins. Of course, labor intensive, but with a different skill set, not the same skill set. So for next couple of years, you will see the boom in terms of this kind of skill set. It will be high demand. Of course, DevOps solves some problems like CI/CD, as I said, because continuous integration deployment means you are talking about making faster code delivery. That is what getting software update market to the faster, more stable. And key thing here is that because you will be implementing smaller changes, so you will have less chances of bug. Infrastructure automation, as I said, API driven development in AWS. Managing relationship, because you saw in the diagram I showed, the DevOps team has actually glue between developer, QA, and operation team. So they need to work as a team, and that is a very important skill. And failing intelligently. This means anytime you do any changes in the infrastructure, you always do as a part of code. That I'll talk later about what is infrastructure as code and why it is so important. And that is what I would say one of the core pillars of DevOps. So these are some legacy jobs which are at risk because of cloud migration. I will say, for example, you have your server administrator, you have like DBAs, production support, build engineer, QA automation, product program analyst. Because the example is that as you need more and more servers on the cloud, you don't need so many server administrators. Similar applies to DBAs, because once you move to a kind of a self-managed database like RDS or Oracle Autonomous Database, the requirement for DBA will dramatically go down, and the managing database will become so simple that even developers should be able to manage it. Production support, because you are moving towards the SaaS product, they are more stable, so you have a less of it. Build engineer, you're talking CI/CD automation, you don't need build engineer. QA automation, of course, you need an automation developer, but to hook it up with the system, you don't need that anymore. And pretty much old style of program analysts, legacy platform things will be things of past. So what is happening here? So basically, all these legacy jobs, these will transform or already been transformed as a DevOps. So it's not like DevOps person is some new kind of something. DevOps means that that person should be able to perform all these duties. So DevOps is not like you come and you don't do anything. And why they are paying you extra? Because you are doing actually 5 people job. You are the admin, you are the DBA, you are the config management, you are the build engineer, you are the developer in some cases, and you also manage the platform. And many places they do the rotation, like a pager duty kind of thing. So even the pager duty integration is a job of a DevOps engineer. So it is a full stack of things. So you right now, instead of actually hiring one sysadmin, one DBA, almost 5 people, what they can do, instead of hiring 5 people, they will hire 2 DevOps. And probably they will take the salary of 5 people and give to these 2 people. This is the only simple math I'm telling you. That is why DevOps are paid a little bit more than market. So on an average, like a developer salary could, it's I think I have seen up to more than 30%. I'll say to the ballpark. So this is the looks like. And when I'm talking about, so DevOps is, as I mentioned, it is the developer plus operation. So you have to wear 2 hats. So developer side is, I will say, from the skill set side, you should have at least, like, I will say Python is a good thing to have. Python, building jars, Jenkins, Git, and operation side you're talking about Linux admin, Kubernetes, Ansible, Bash, and monitoring. You combine both 2 skill set, you achieve DevOps. So when I'm talking about DevOps, you need to be able to perform these jobs and you should be comfortable doing that. Not only just clicking on Amazon buttons. Those are, I would say, cloud ops rather than DevOps. Then DevOps principle, this is actually the kind of a philosophy, as I always mentioned, DevOps is a philosophy rather than a job description. So to reduce organization silos, as I already mentioned, because you'll be working with different teams and you break the barrier, implement gradual and small changes because you'll be doing agile based changes. So you will be having smaller changes which will be shipped. Implement tooling and automation. Wherever possible, you do implementation, tooling, and automation. You don't do one thing twice, and accept failure and address them so that do not happen again. It means anytime you do, you fix it as a part of a code, like infrastructure as code. This is how you achieve it. So if I'm talking about DevOps and SRE, so if DevOps is a philosophy, I would say SRE is an implementation of it. And most popular tools in the market for DevOps tooling, you can talk about Maven, Git, Jenkins, Jira. So build automation, test automation, deployment automation, monitoring, alert, failure, and rollback. So these are pretty much, I would say, the most common tools, and I would say common job responsibilities done by DevOps people. Development or operation, same again, similar chart. So as a development side, what you will be doing as a DevOps, you'll be supporting developers, supporting QA, doing the build automation, making build pipeline, also known as Jenkins pipeline or CI/CD pipeline, application development, small application development, you may have to do it, and tooling in terms of Git, Jenkins, Maven, TeamCity, Bamboo, SonarQube. These are the tools on a developer side. And operation side, what you will be doing, you'll be doing infrastructure provisioning, like creating VMs, network, load balancer, keeping production server up and running. That is the most important thing. Security and audit, orchestration, and tools you'll be using Ansible, Kubernetes, Puppet, Chef, and these. And this all thing has to be done by one person. This is why it's called DevOps, developer operation. So a typical continuous integration pipeline looks like this. You have a developer, they commits the code, it goes to GitHub. This is basically social coding. And from GitHub hook, a automatic build is triggered by Jenkins server. And if there is some issue happens, it goes to developer. If everything is good, it goes back to production. So this is a very simple example of continuous integration and continuous deployment. So this is all about DevOps and what it is, and a quick introduction about continuous integration. We'll talk to you in the next lecture. Thank you for joining. Bye.